All right, so on the driving range, Tiger Woods practices his swing with a particular club by hitting many, many balls. When Tiger hits his driver, the distance.
The driver's name.
Well, yeah, but he hits his driver. I don't know. I think it's supposed to say uses. But yeah, I was like, The distance the ball travels follows a normal distribution. See, that right there is why I'm a math teacher, not an English teacher. So the distribution is n of the mean of 304 and a standard deviation of 8. So what percent of Tiger's drives travel at least 290 yards? And it says to draw a picture. We aren't going to draw a picture for that one, but, well, we could, technically. Well, just do it over here to the side. So we have 304 in the middle, standard deviation of 8. So somewhere over in this general area. At least that implies that it's anything beyond that we're looking for. So we could find the z-score, go through, find the percent that way. But we can also do it with our calculator. So we're gonna do the normal CDF for this one. So on your calculator, if you hit second and then the VARS button, which is for distribution, I think is what it says.
What button?
The VARS button, it should be over to the right near the stat button. But you hit second and distribution. Then it should be like number 2, I think. Yeah, so it's going to say normal CDF. So then it should bring up a thing. It should say something like lower, upper, mu, and sigma or something like that, I think. So your lower value is going to be, it's at least 290, so 290. You can put any really large number you want, okay? I would go probably like 400 because if there's a standard deviation of 8, there's no way that he's going to ever get to 400. That's just, if it happened, kind of insane. So I would just say something like 400. You may see on your calculator that it shows you 1e to the 99. If it has that, there's nothing wrong. You don't need to change it. You can leave it. But with a problem like this, you don't have to go out that big. And then it asks for your mean, which is 304, and your standard deviation of 8. And then if you hit enter, it'll give you out a percent.
340.
Yeah. So each spot, because when you type it in your calculator, when you hit enter and it copies the thing down.
And then hit the paste button.
Yeah. When it copies it down onto your calculator, you may have to hit enter again for it to do it.
Okay.
But it'll look like this. So some people that have the older calculators, they have to type it in like this. They just have to know what goes in each spot. It doesn't prompt them for what goes in the spot. So for example, Peyton has a calculator that's probably 20 years old, but it's still technically a TI-84. So she would actually have to manually type them in if she was going to do it on hers. But both of those calculators should ask you for the prompts. So anyways, if it didn't give you an answer, you have to hit enter again. Sometimes it does, sometimes it doesn't. But what did it give you? 0.9 what?
0.9599.
Okay, so 0.959, so that's going to be 0.96 or 96%. So 96% of hits or drives go past 290 yards.
I just suck at golf in general. My little Zach, on the other hand, he's so good at golf. It's unbelievable. He plays tournaments every Saturday, and he's so good. He's got a 42 on 9 holes or something. Apparently that's really good.
Yeah, that's so many. That's 6 over par. Because par is 36.
Yeah.
6 over par is not bad.
All right. So then, what percent of Tigers' drives travel between 305 and 325 yards? So that just for perspective. Okay, if your mean is at 304, then basically we're looking. Whoa. Undo. Go back. Basically, we're looking essentially just in this little area here from 305 to 325. Oops. So now we're using the same function, but we're putting 305 and 325 in the first two spots. So it'll be the normal CDF of 305, 325, 304, and 8. And I always say to write down the calculator function that you're using and the order that you put them in, because when you get to like the AP test and stuff like that, like if that's the way you did it, then they know how you solved it. Like they want to know everything you put in to give you full credit.
That's so annoying.
So, yeah. And then it also helps me because like if you put something in wrong, or if you have all the right stuff written down and then you get the right thing, like you have the wrong answer, then I'm going to be like, okay, you must have just typed something in wrong or whatever.
0.446.
0.45 or 45%. All right, so the next one, what distance would a ball have to travel to be at the 80th percentile of Tiger's drive lengths? Draw a picture. So this is talking about a drive farther than 80% of his drives. So, this one, we are looking for a function called INV norm. It should be like number 3, I think, yeah. And when you click on it, it's going to ask you for the percentile, but it's going to want it in a decimal, so 0.8, and then mean and standard deviation. Yeah, sorry, the area is the percentile. I couldn't remember what word they used to describe that.
Because there's left, right, and center. On my calculator. For the tail.
That 310.7.6.
Do me a favor, click the left one because I'm trying to remember because my calculator doesn't do it that way, so I forgot. That's the one that I was saying yours doesn't.
310.73.
You did left?
Yeah.
Okay. So yes, that's.
So should I just always do
No, I'm going to show you why because in a minute he's probably going to have to do like a 1 minus thing.
that? Okay.
But I have to remember what it is because I don't have it written down, but I know it's one of these that's coming up. Because the picture of what this one would have looked like, I should have drawn this before, but you have your mean at 304, and we're trying to find this X value here that's at the 80th percentile, so we want the stuff that's on this side.
Okay.
So then 75% of Tiger's drives are above what drive length? So this one, okay, this is where Joel, yours is going to be different. So Ethan, for the calculator that you're using, we have to do INV norm. You're both doing INV norm, but for the old calculator, you have to do basically 1 minus 0.75 because we want above. So in here you're doing 1 minus 0.75 or 0.25.
On mine, I'm doing right.
You're doing 0.75 right. Yeah.
That makes sense.
So then 304, 8. So on the new one, it's INV norm of 0.75,
290.
304, and 8. And then you're going to have to click right. So what did you say it was?
298.6.
Okay. 299 yards. So with this one, because it wants above what drive length, we're looking at, okay, again, the middle is at 304. So we're looking at above what drive length, we're looking at everything on the right side. One minus 0.75. So like you needed to get for the answer for yours, you needed to do 0.25. So then the next question.
I thought it was saying
Oh.
like divide by 0.25. And it's like, wait, that's not
It's a really curvy division symbol.
Yeah.
Between what two drive lengths is the IQR and what is the IQR? So the IQR is what in general? The middle what?
Yeah.
Which is how, like what percent?
50.
50%. So the middle 50% is going to be 25% to 75%. So that's what the first part is asking. So 25% and 75%. So
Could you just like do 304 times 0.25 to get 25%? Oh wait.
I don't think that's going to give it to you.
Oh wait.
But you already found the 25% one. It's 299 yards. Then what you need to do is you need to go back and so Joelle, like you already had the 0.75, but you need to do it for left.
Okay.
And then, so Ethan, instead of 0.25, you can actually type in 0.75 now to get that one.
309.
So 309. So then your IQR would be what? 10. So 309 minus 299, which is 10.
That was pretty easy.
So yeah, it's not bad. It's a matter of a lot of times these two functions get mixed up because people forget what it's asking for. If you're given the percent to start with, it's INV norm. If you're trying to find the percent, it's normal CDF.
Okay, and how do you know whether you're supposed to use right or left, or like?
It's a matter of what the question's asking for. So
Okay.
like this one says, what distance would the ball have to travel to be at the 80th percentile? So it's going to be the left side because you're wanting the stuff that's up to 80% or up to the 80th percentile area wise. The other one was right because it says above what drive length. If it said something like, I want to say it says something like between is when you use center.
Okay, so if it gives you the percent, then you do.
But typically for a center problem, like if you if you want to test it, I don't know if it works, but if you do the 50% and then the 304 and the 8 and hit center, it might have given you this number. But I'm not positive. I'm trying to remember because see if there's one that we use center for later in this worksheet.
Use 50%.
Yeah.
And then 304. No.
No, okay.
It gives me like the parentheses basically. That's so weird. That looks weird. I don't know. It doesn't give me a number. Like.
Okay. I'm sure we'll find one that's a center one, but most of the time we're using left and right.
Yeah.
So.
We gotta answer the question.
Huh?
We gotta answer
So
the
when is a normal model appropriate?
Oh. I was like, what do you mean we have to answer the question? I was like, I think that's all that's on that page. All right. So when is a normal model appropriate?
That's a great question.
What has to be true about the histogram in terms of its shape? Not the histogram. The normal
Symmetric.
histogram. Okay, it's got to be symmetric. So histogram is symmetric. What else has to be true about it?
I mean unimodal.
Yep, symmetric and unimodal. And then I don't think we wrote this one in your notes, but the other one is that the normal probability plot is a straight line. And then just something to note, if the histogram is unimodal but not symmetric, the normal probability plot is not linear, and thus we can't use the normal model. When you're done, you can start typing all these numbers into a L1.
And I knew that was gonna happen. The other day on our homework, there was so many.
I try not to do something super obnoxious when you have a test, like 50 numbers or something, because I'm like, that just takes a long time.
I forgot it's second.
It should just be stat and then edit. And there should be enough numbers there to overwrite whatever was there before, but you can clear the list if you want. Huh?
You guys have abilities in it?
Yeah.
Yay.
There should be 44 numbers when you're done.
And they are decimals.
To get what?
histogram.
Second y equals to get the stat plots.
Which one do I put in?
Whichever one is already on. One of them should say on. If it, okay, then you can pick your favorite one, and then you'll turn it on. But don't hit the on, like don't hit the like all plots on or turn plots on or whatever, because that'll turn all of them on, and then it won't graph.
Yeah, I put.
No, you have to like. Did you hit enter on the one that you wanted? Then you need to pick the thing that looks like a histogram. And then, if you put all your stuff in L1, it should already be set for you. And then you just need to go down and hit enter. And then hit graph. Or there may not be an enter. Just hit graph.
Is it supposed to have like a ton of horizontal lines?
Oh wait, sorry. Hit zoom.
Zoom.
6. Zoom
I
stat.
was pretty sure I was doing something.
If it was already set from before, it may have just automatically done it, but if it didn't, that's why. Is it not working?
Wait, so you said
So after you have all that stuff like typed in or whatever about the plot, hit zoom 6. Wait, is it zoom 6 or zoom 9?
9.
Zoom 9 for zoom stat.
change fonts.
It's on the top middle.
That's me all the time. I'm like, where's the pie?
I'm taking this thing off. This is really irritating me.
Mine is still giving me horizontal lines. It's so weird.
Go to
But
your
it
click.
has a histogram.
Click y equals.
That's.
This thing is so tight. Why did she put this on so tight? Ow.
Oh wait.
If you hit y equals, if there's something in your y equals, you need to clear it.
Yep, that's what it is. Oh, you don't.
Did that do it?
Yep.
Okay.
Thank you.
So then copy down like roughly what it looks like. I don't know. It should look something kind of roughly like that, I think. Ballpark. Is that what y'all's looks like?
Some.
Or at least kinda. So, in terms of shape, what does this kind of look like? Hmm?
I said you don't know. And skew right. And left.
I said. I thought it was, or at least, mostly.
Huh?
I thought it was.
I would say it's kind of symmetric. It's like, I know it probably doesn't really look like that, but because there's like the one on each side, and then these are like kind of, it's because of what you're going to find out later is why I'm saying that. Just say approximately symmetric. Or roughly symmetric or something. Because the question that we're going to do in a minute, because it's going to be a normal model, so it has to be, like, yeah. And you'll see why we can when you do the thingy in a minute. Okay. All right, so calculate the one variable statistics. So, you need a min, Q1, median, Q3, max, and then because you're going to need it to draw your normal model, X bar and S, so your mean and standard deviation.
Wait, the min is 9.4. Q1 is 13.55. Median is 15.8. Q3 is 17.5. Max is 22.8. Then you have 15.64. And then the S, in mine it says SX.
That's
Same
it.
thing?
Yeah.
2.56.
And then we should check for outliers just in case, and if nothing else, it's extra practice. So outliers, well, what is our IQR, first of all?
4.05. Wait, no.
Other way.
Subtract 3.99.
Yeah. So then we can test it. So Q1 minus 1.5 times 3.95. I guess I should replace Q1 with 13.55. And then Q3 is 17.5 plus 1.5 times 3.95.
7.625.
I'm just gonna round it to 2 decimal places. Make it a little bit easier.
Uh, 11.5.
Are you sure?
5.8.
No. Are you sure about that number? Because Q3 is 17.5, so it's got to be bigger than 11. Add, not subtract. I think that's what probably you did.
That's what I did. Okay, 23.42.
Okay. There we go. All right, so the next one says to calculate the percent of observations that fall within 1, 2, and 3 standard deviations of the mean. How well do these results compare to the 68, 95, 99.7 rule? So we're going to see basically if the rule holds for this. So I would draw first a little thingy thing. There we go. The bell curve normal model. And I would put on here like your mean, and then I would draw out what all of them are supposed to be. So 15.64, write smaller. 15.64, and then I would figure out what the other ones are supposed to be first by adding or subtract.
15.64.
Yeah, it's this value, and then you're gonna add 2.56 to each, like, to it to get these other ones, and then subtract it to get the other side.
The first one is 18.2. And then 20.76. And then 23.32.
And then you just have to subtract to go the other way.
13.08 and 10.52 and 7.96.
All right, so then it says to calculate the percent of observations that fall within 1, 2, and 3 standard deviations of the mean. So you could go through the list and you could sit there and you could go through all 44 numbers and then try to keep track of how many it is. But if you hit stat on your calculator and then sort, and it'll say sort A, and then it'll bring up a parentheses, you can type in L1 to that, and it'll sort the numbers in numerical order for you. So then you just have to see how many fits in each one. Or in like each of the standard deviations. So you'll just have to count them up.
Is it air?
Huh?
Is it
Mine says done.
Did you? Okay, so then hit your list and it'll come back up. And then there should be something that says sort A, and then hit list, and then hit like enter for L1, and then tell it to like do it.
Oh, that's so cool.
Oh, yeah.
And then if you hit the stat button and then edit, it'll bring up the list of numbers in order. So then you can tally where they go and like count them up. So you could go down and you could do like start at the like when you get to like 13.08, and you could count how many you have till you get to 18.2. And then you're going to do that number out of, the total number is 44. So you're looking for however many out of 44 for each. And we didn't really answer the question, but were there any outliers based on the fences? Kind of forgot to answer that question. Are any numbers bigger than 23.42 or less than 7.63?
No.
No, so no outliers. So that means that within 3 standard deviations, all the numbers you have should be within that. So like your 3 standard deviations should be all 44 numbers.
Okay, I got 13 over 44.
13.
Yes.
We're trying to find.
How many numbers are between 13.08 and 18.2?
Oh, 18.2. I only did to 15.6.
Okay, I was like,
Okay.
there's supposed to be a lot more than that.
Let me count again.
Sounds right. Okay, and so then you need to find out how many are between 10.52 and 20.76. But you already know how many is in the 13.08 to 18.2, so all you need to do is add the ones from 10.52 to 13.08 and 18.2 to 20.76. Or you can recount.
11 plus 31.
So then divide those out and see what the percentages of these end up being. All right, great. We both agree then. All agree, whatever.
0.705.
So 70.5%. How about the next one?
95.5%.
And the last one? 100%. So comparatively to the 68, 95, 99.7 rule, what do we think?
It's somewhat similar.
So it's pretty similar to the rule. I guess I should say to the rule because otherwise it's just written there. Use your calculator to construct a normal probability plot. Under your, when you did the stat plots, I think is where it is. I'm trying to remember. But when you did the stat plots, one of them should look like basically a whole bunch of dots that like touch when you look at the thing. I might have to come actually look at it and see what they. I might have to look at the options y'all have because I don't remember what the normal probability plot. So hit the stat plot, so second stat plot. So it's gonna be this one, I think. That one, second, and then that. So I'm gonna hit enter to open up the first one. So it's gonna be this one. Yeah, the one below it. You have to keep arrowing to the right. And then hit enter so it selects that one. And then if you hit, what else does it ask you for? Yeah, and then you can just hit the zoom 9.
Whoa.
So in theory, you should see something.
Oh, I lost.
Just hit the graph button again and it should come back up. In theory, you should see something that looks kind of like that. Sort of. Okay. So, what does this kind of look like? Like, how would you describe the order that those dots are in?
I would say skewed left, but I don't know if that's actually what you're looking for.
Just like, if I was to connect the dots, what is it going to look like? A line.
Okay. I was like, I have no idea.
So, the normal probability plot, which is what this is approximately linear. So, a normal model is okay.
We have 3 minutes.
All right. So, having inspected the data from several different perspectives, okay, so we've seen the empirical rule, we've seen the normal probability plot, and we've looked at the histogram. So having seen it from several different perspectives, do you think these data are approximately normal?
Yes.
Yes. Write a brief summary of your assessment that combines your findings from part A to D. So yes, approximately normal. I would comment that the normal probability plot is approximately linear. It followed the 68, 95, 99.7 rule. Histogram was unimodal, approximately symmetric. So all conditions that we mentioned are met. So we can use the normal model for 15.6, what was it? 4 and 2.56. TBD on if we're gonna do the last page or not. I might have.
Egg sizes.
I might have y'all attempt that one like on your own tomorrow, and then we'll go over it. Test is definitely not gonna be Friday because we need to do the review questions still. Do y'all want the problems for homework today?
Yeah,
Okay.
I will.
I won't make them do till Friday though, so that way you still have time to